All right, so today we are going like way deep into geometric vision.
Yeah.
All about how computers are learning to see the world in 3D just like we do.
Yeah.
Like it's not just sci-fi anymore. This stuff is powering self-driving cars, robots, even those AR filters that everybody plays with on their phone.
Right.
We've got a ton of technical explanations here, so let's just break it all down, figure out how it works.
That sounds great. Yeah.
So I've been seeing this term projective geometry pop up everywhere.
Yeah.
It kind of sounds intimidating, honestly.
It might sound daunting,
Yeah.
but the basic idea is really simple.
Okay.
Think of like a light source, projecting shadows.
Okay.
That's kind of the basic idea, right?
Yeah.
You take the 3D world and you're flattening it onto a 2D image like a camera does.
Okay, so it's like capturing a whole world on a flat surface, basically.
Exactly.
That makes sense.
Yeah.
But how do we go from that flat image back to understanding 3D?
Well, that's where perspective comes in.
Okay.
Think about, you see those classic paintings?
With the roads converging at a vanishing point.
Right.
That's perspective in action, and that's really key for understanding how cameras see.
And how we extract that 3D information.
Exactly.
From those 2D images.
Yeah.
It's like art class is suddenly relevant again.
Right.
But we're not just dealing with static paintings here.
Yeah.
We're talking about cameras capturing the real world,
Yeah.
which is constantly changing.
Exactly.
So how do we, keep up with that?
So that's where camera models come in.
Okay.
They kind of give us this mathematical framework for understanding the relationship between that 3D world and the 2D image captured by a camera.
Okay.
We have to account for things like focal length, essentially zooming in or out,
Right.
lens distortion,
Distortion, yeah.
the camera's position and orientation, all those sorts of things.
Okay, so is that why sometimes photos look a little bit warped, especially near the edges?
Precisely.
Okay.
Real-world lenses aren't perfect.
And these, distortions need to be accounted for when we're trying to get that accurate geometric information from the images.
Makes sense.
Yeah, there are all sorts of different camera models out there.
Oh, okay.
Each with different levels of complexity, designed to handle, different distortions and scenarios and so forth.
So it's not just point and shoot.
No.
There's a whole lot of math happening behind the scenes to really make sense of those images.
Absolutely.
But let's say we have a perfectly undistorted image.
Okay.
How do we actually get that 3D information out of it?
Right.
Is it really possible to make a computer see depth?
It is.
Okay.
And one way to do that is by using multiple images of the same scene.
Okay.
This is where epipolar geometry comes into play.
All right.
So think about how we see in 3D with two eyes.
Right.
Each eye captures a slightly different view.
Yeah.
Our brain combines those views to perceive depth.
So are we saying computers can get 3D vision, by mimicking how our eyes work?
That's the basic idea.
Oh.
So by analyzing the relationship between two images taken from slightly different viewpoints, we can actually extract depth information.
Wow.
There are these, special lines called epipolar lines
Okay.
that actually connect corresponding points in the two images.
Okay.
And those lines kind of hold the key to understanding how far away objects are.
Epipolar lines. That's so fascinating.
Yeah.
So by analyzing those lines, we can actually figure out how far away things are in an image.
Exactly.
It's like those 3D movies,
Mhm.
where two slightly different images are projected, and then our brain merges them
Right.
to create that illusion of depth.
That's a great analogy.
Yeah.
So those 3D classes are essentially mimicking what geometric vision algorithms are doing,
Right.
just in a much simpler way, obviously.
This is incredible. So we've got one camera, we add another one, and suddenly we have this whole new dimension of information.
Right.
But what happens if we add even more cameras to the mix?
Yeah.
Does it just keep getting better?
It does.
Okay.
And that's where multi-view geometry comes in.
Okay.
So now imagine having not just two,
Right.
but multiple cameras, all capturing a scene from different angles.
Okay.
By analyzing all those views, we can build an even more accurate and detailed 3D representation of the scene.
Okay, now we're talking.
Yeah.
So we're building a complete 3D model just by moving a bunch of cameras around a scene.
Exactly.
That's amazing. But what are some of the ways that this 3D information can actually be represented? It's not like the computer's actually sculpting something out of clay, right?
No. We can represent that 3D data in a number of different ways.
Okay.
We can create point clouds,
Okay.
which are basically collections of points in 3D space
Right.
that represent the shape of the scene.
Okay.
We can also generate meshes,
Okay.
which are like interconnected polygons that form the surfaces of objects,
Yeah.
giving us a more sort of solid visual representation.
Okay.
And we can even create volumetric models, which represent the entire 3D space occupied by objects, including the empty space between them.
So it's like we're giving computers the ability to see and understand the world in a way that was unimaginable, just a few years ago.
Absolutely.
Paint clouds, meshes, volumetric models.
Yeah.
Like we're giving them this whole new language to describe the world around them.
It truly is a revolution in how computers perceive the world.
That's incredible. So now that we have a good grasp on kind of like the foundation,
Yeah.
let's start digging into the applications.
Sure.
What can geometric vision actually do?
Right.
I mean, besides making those cool 3D models, what are some of the tasks it can actually perform?
So one of the most fundamental tasks is depth estimation.
Okay.
And we're not just talking about measuring distance here,
Right.
but understanding like the shape and layout of objects and scenes in 3 dimensions.
Okay.
Think about like a self-driving car
Mm-hmm.
that needs to accurately perceive the distance to other cars, pedestrians, obstacles.
Right.
That's depth estimation in action.
Right.
And it's crucial for safe navigation.
Depth estimation, that makes sense.
Yeah.
But it seems like there's a lot more to it than just measuring distances, right?
Oh, absolutely.
We're talking about understanding like the entire scene,
Yeah.
the relationships between objects,
Yeah.
even the spaces between them.
Exactly.
It's about building a complete 3D understanding of the world,
right.
not just a collection of isolated measurements.
Exactly.
So, all right, so we've got depth estimation. What else can this amazing technology do?
Well, how about building a 3D model just by moving a camera around a scene?
Wait, hold on.
Yeah.
We can create a 3D model just by moving a camera?
That's right.
That sounds almost too good to be true.
It's called structure from motion.
Okay.
And it might sound like magic,
Yeah.
but it's all based on, these solid geometric principles.
Yeah.
By analyzing those subtle changes in the images as the camera moves,
Yeah.
we can actually reconstruct the 3D structure of the scene.
So it's like piecing together a 3D puzzle from like a sequence of 2D snapshots.
Exactly.
That's seriously impressive. So we've got depth estimation, structure from motion.
Mm-hmm.
It seems like geometric vision has like this whole toolbox of tricks up its sleeve.
Yeah.
What other like amazing feats can it pull off?
Well, there's camera tracking,
Okay.
which is crucial for augmented reality.
Okay.
AR, right?
Yeah.
So it's the technology that allows, those virtual objects to seamlessly blend with the real world as if they were actually there.
Like those AR games where you can battle like virtual creatures in your living room.
Exactly.
Yeah, that's camera tracking at work, making sure that those creatures stay like anchored to the real world.
That's right.
It's like we're stepping into those sci-fi movies where holograms are just part of everyday life.
Exactly.
This is all so fascinating. We've gone from like basic geometry to building these 3D models to merging virtual objects with the real world.
Yeah.
It seems like geometric vision is like popping up everywhere.
It is.
It's truly revolutionizing how we interact with technology and the world around us.
Absolutely. And it's only going to become more pervasive as the technology advances.
Speaking of advancements, I have to ask about kind of the elephant in the room, deep learning.
Right.
It seems like the buzzword for pretty much every field these days.
It is.
So how is it shaping the world of geometric vision?
Well, deep learning is a game changer, for sure.
Okay.
And it's having a profound impact on geometric vision.
Okay.
Think of it as like this powerful tool
Okay.
that can really boost the accuracy and efficiency of these traditional geometric vision methods.
So it's like taking those already impressive techniques and giving them like a turbo boost.
Exactly.
Okay, so what exactly is deep learning doing to achieve this?
So one key contribution is in feature extraction.
Okay.
Traditionally, we had to hand design algorithms to detect specific features in images, like edges, corners, textures, things like that. But deep learning can actually learn these features directly from the data.
Wow.
And it could do so with, incredible accuracy and efficiency.
So instead of us telling the computer what to look for, it's figuring it out on its own.
Exactly.
That's pretty remarkable.
Yeah.
But how does that translate into actual improvements in, like, geometric vision tasks?
Right. So, for example, in 3D reconstruction,
Okay.
deep learning can help identify corresponding points in multiple images
Okay.
with much higher accuracy,
Okay.
even if the viewpoints are vastly different
Right.
or the lighting conditions are challenging.
Makes sense.
And this leads to more detailed and accurate 3D models.
So deep learning is like this super-powered matching game,
Right.
finding these subtle connections between images that we might miss.
Exactly.
And this is all happening automatically.
Yeah.
It's mind-boggling to think about the level of complexity involved.
It is.
But it also makes me wonder, are there any limitations to this deep learning approach?
Well,
Can it really handle everything we throw at it?
well, deep learning has revolutionized many areas of computer vision.
Mm-hmm.
It's not a silver bullet.
Okay.
There are still challenges to overcome.
Some challenges.
Yeah.
I'm intrigued. Tell me more. So you were saying deep learning, it's not perfect.
Yeah, it's not a silver bullet. There were definitely still challenges.
Challenges? Like what? I'm curious.
One of the biggest ones is just the amount of data these deep learning models need for training.
Okay.
We're talking about feeding them millions, sometimes even billions of images.
Wow, billions. That's a lot of data.
It is.
So where does all that data even come from?
It comes from a variety of sources.
Okay.
There are publicly available data sets, research labs,
Right.
even companies that are collecting and annotating their own data.
Okay.
But gathering all that data, cleaning it, labeling it, it's all really time-consuming and expensive.
It sounds like a logistical nightmare.
It can be, yeah.
So data is a major bottleneck, basically.
It is one of the big ones.
Are there any other challenges that researchers are kind of grappling with?
Yeah, another big one is computational complexity.
Okay.
So these deep learning models can be incredibly complex.
Yeah.
With millions, sometimes billions of parameters that need to be adjusted during training.
Wow.
So this obviously requires, very powerful hardware.
Right.
And that can make it difficult to deploy these models on, more resource-constrained devices.
Right. Not every device has the power of a supercomputer or something.
Exactly.
So data and computational power, those are two big hurdles.
Yeah.
But what about the models themselves?
Yeah.
Are there any inherent limitations to what deep learning can achieve in geometric vision?
Well, one limitation is that they really rely on those statistical patterns in the data.
Okay.
Deep learning models are essentially learning these statistical relationships between the input data, like the images, and the output predictions, like the depth maps or the 3D models.
Right.
And while this statistical approach is incredibly powerful, it can sometimes struggle with situations that deviate significantly from that training data.
So it's like they're learning the rules of the game,
Right.
but sometimes the rules change,
Right.
and they don't always know how to adapt.
Exactly.
Okay.
So, for example, imagine like a self-driving car
Right.
that encounters a totally new object or scenario
Right.
that it's never seen before in its training data.
Okay.
The model might really struggle to make accurate predictions in those kinds of situations.
So that highlights the importance of having really diverse,
Absolutely.
comprehensive training data that covers as many real-world scenarios as possible.
As many as you can.
But even with the most extensive data, there's always going to be the unknown, right?
Always, yeah, the unexpected.
Yeah. Are there any other limitations that we should kind of be aware of?
Another challenge is robustness
Okay.
to noise and disturbances.
Okay.
Real-world images are rarely perfect.
Right.
They can be affected by, sensor noise, lighting variations, occlusions, all sorts of other factors that can degrade the performance of these algorithms.
So it's not just about the geometry. It's about dealing with the messiness of the real world, right? Images can be blurry, distorted, partially obscured, all those things.
Absolutely.
So how are researchers addressing this issue of robustness?
Well, they're developing more robust algorithms that can handle those real-world imperfections.
Okay.
So they're exploring things like data augmentation,
Okay.
where you artificially introduce, noise or distortions to the training data.
To make the models more resilient, basically. Okay.
They're also developing algorithms that can kind of explicitly model and account for these uncertainties.
So it's like giving those models a crash course in real-world photography.
Yeah.
Teaching them to see through the blur, the shadows, the imperfections.
Exactly.
It sounds like there's a lot of ongoing research
Oh,
to make these models more reliable and adaptable.
Absolutely. It's a very active area of research.
But even with all these challenges, the progress in geometric vision has been, astounding. Really.
It has, yeah.
It's almost like we're crossing this threshold into, a sci-fi world where machines can see and understand the world just like we do.
Yeah, it's a very exciting time to be working in this field.
It is. It is. And as this geometric vision technology matures, the applications are only becoming more diverse
Yeah.
and impactful, right?
Absolutely.
So let's talk about those applications.
Okay.
We've talked about self-driving cars,
Right.
augmented reality.
Uh-huh.
But what other areas are being transformed by geometric vision?
Well, in medicine, for example,
Okay.
geometric vision is being used to create 3D models of organs and tissues
Okay.
from medical scans.
Okay.
So this enables, more precise diagnosis and treatment planning.
So doctors can actually visualize and interact with a 3D model of like a patient's heart or brain.
Exactly.
That's incredible.
Yeah.
How is that like changing the way surgeries are performed?
Well, it's allowing surgeons to actually plan and rehearse complex procedures
Okay.
in a virtual environment.
Wow.
So this can help reduce risks and improve outcomes.
Makes sense.
Yeah. For example, they could use these 3D models
Right.
to determine the optimal approach for a surgery
Okay.
or to practice the placement of implants or prosthetics.
It's like having a dress rehearsal for surgery.
Right, exactly.
That level of precision and planning is remarkable.
It is.
What other areas of medicine are kind of benefiting from geometric vision?
It's also being used to develop personalized medicine,
Okay.
where treatments are tailored to an individual's specific anatomy and physiology.
Okay. Yeah.
So by analyzing 3D models of patients' bodies,
Mm-hmm.
doctors can create, custom-fit implants or prosthetics,
Right.
or even design personalized drug delivery systems.
Wow. So we're talking about a future where medical treatments aren't like one size fits all,
Right.
but they're truly tailored to each individual.
Exactly.
It's like the ultimate in personalized care.
Yeah.
So what about other fields? Are there applications beyond medicine
Yeah.
that are kind of pushing the boundaries of what's possible?
Absolutely. In archaeology, for instance,
Okay.
geometric vision is helping to reconstruct ancient artifacts and sites
Okay.
from fragments and photographs,
Yeah.
providing these invaluable insights into our history.
So it's like those forensic shows where they like reconstruct a face from a skull,
Yeah.
but on a much grander scale, they can
Exactly.
actually recreate like entire buildings or monuments from just a few pieces.
Yeah, by analyzing the shapes and positions of those fragments,
Wow.
they can virtually piece them back together.
That's amazing.
Yeah.
It's like bringing the past back to life, piece by digital piece.
It is.
That's amazing.
Yeah.
What about like applications in the realm of entertainment?
Oh, yeah.
I can imagine geometric vision playing a big role in movies, video games, virtual reality.
Absolutely.
Yeah.
It's powering the creation of incredibly realistic virtual worlds.
Right.
For all those things, movies, video games, virtual reality experiences,
Yeah.
it's allowing, filmmakers to create these breathtaking special effects.
Right.
Game developers to build really immersive environments.
Yeah.
VR enthusiasts to explore these fantastical worlds that feel incredibly real.
It's like stepping into those movies and video games,
Yeah.
becoming a part of the action,
Right.
instead of just watching it on a screen.
Exactly.
And it's all thanks to the power of geometric vision.
It is, yeah.
But beyond the entertainment value,
Yeah.
are there any like practical applications of
Yeah.
these virtual worlds?
Oh, absolutely. They're being used for training and simulation
Okay.
in a variety of fields, from aviation to
Uh-huh.
healthcare to manufacturing.
Okay.
They provide this safe and cost-effective way to practice complex tasks, learn new skills, experiment with different scenarios.
So it's like a flight simulator for surgeons,
Right.
or like a virtual factory for engineers.
Exactly.
Wow.
They can practice their skills, refine their techniques without any real-world consequences.
It's a game changer for education and training.
It really is.
That's amazing.
Yeah, and as the technology continues to advance,
Right.
these virtual worlds are only becoming more realistic and immersive.
It's incredible to think about all the ways that geometric vision is transforming our world,
It is.
from like self-driving cars to personalized medicine to these virtual worlds that feel so real.
Yeah, it's really remarkable.
It's really remarkable, but with all this amazing technology,
Yeah,
it's important to consider the potential impact on society as a whole.
absolutely.
As we integrate these like powerful tools into our lives,
Yeah.
what are some of the like ethical considerations that we need to be mindful of?
Well, that's a crucial question.
It is.
As with any powerful technology, geometric vision comes with incredible opportunities,
Right.
but also potential challenges.
Right. It's not just about the cool factor anymore. It's
Yeah.
about understanding the like broader implications.
Exactly.
So we were talking about the broader implications, right? Like what are some of the ethical considerations that we need to be aware of as geometric vision becomes more, integrated into our lives?
But one big one is privacy.
Okay.
I mean, as these geometric vision systems get more sophisticated,
Right.
they could be used to, track individuals,
Right.
analyze their movements,
Okay.
even like infer their intentions,
Right.
all without them even knowing.
It's like those sci-fi movies where everyone is constantly being watched and monitored.
Right.
That's a little unsettling.
It is a concern.
Yeah. Are there like any safeguards in place to prevent these systems from being used for, like surveillance or other like intrusive purposes?
Well, there are growing concerns about that,
Yeah.
definitely. And policymakers and, privacy advocates are working to establish guidelines and regulations
Okay.
for the responsible use of these technologies.
Okay. So regulations to make sure it's used ethically.
Exactly.
Okay. That makes
And one important step is just transparency.
Okay.
So people are aware of when and how these systems are being used.
Transparency is key. People need to know if their movements are being tracked or their images are being analyzed.
Absolutely.
But even with regulations, there's always the risk of these technologies falling into the wrong hands.
There always is, yeah.
So are there any other ethical concerns that we should be thinking about?
Yeah, another concern is bias.
Okay.
We talked about how deep learning models are trained on these massive data sets.
Right.
And if those data sets reflect existing societal biases,
Okay.
the resulting systems can actually perpetuate or even amplify those biases.
So it's not just about the technology itself, it's
Yeah.
about the data that feeds it. If the data is biased, the outcomes could be discriminatory.
Exactly.
Yeah. So how can we make sure that these systems are fair and unbiased?
Well, one approach is to carefully curate the training data.
Okay.
Make sure that it's diverse and representative of the population as a whole.
Right. Make sure it's a good reflection of like the real world.
Exactly.
Okay.
Another approach is to develop algorithms that are specifically designed to detect and mitigate bias.
Okay. So build that in from the ground up.
Exactly.
Interesting. It's an ongoing area of research for sure.
It is, yeah.
And it's just crucial that we address these issues to ensure that these technologies are used ethically and responsibly. Bias is a serious concern.
Yeah.
It's a good reminder that technology is a tool, and like any tool, it can be used for good or for bad.
Right.
It's up to us to make sure that these powerful tools are used to benefit society as a whole.
I agree.
But even beyond these ethical considerations, what about the broader societal impact of geometric vision?
Right. How is this technology going to shape the future of work, transportation, entertainment, even our daily lives?
Exactly.
Well, the potential impact is huge.
Yeah.
In the workplace, for instance, geometric vision is already automating a lot of tasks that were once done by humans.
Right.
So this obviously leads to increased efficiency and productivity,
Right.
but it also raises concerns about job displacement
Right.
and the need for workforce retraining.
It's like that classic dilemma of, technology replacing human labor.
Exactly.
On the one hand, it can free us from these, tedious or dangerous tasks.
Right.
But on the other hand, it could lead to unemployment if people don't adapt and acquire new skills.
That's the challenge.
It is a challenge. So how can we prepare for these changes and ensure that, everyone benefits from these advancements?
Well, I think investing in education and training programs
Okay.
that equip people with the skills they need for the jobs of the future is really important.
Okay, that makes sense.
We need to focus on developing those skills that complement these technologies.
Right.
Like critical thinking, problem solving, creativity.
So it's not about fearing the future.
Right.
It's about embracing it.
Yeah.
And equipping ourselves with the knowledge and skills
Right.
to thrive in this, rapidly changing world.
Exactly.
It sounds like geometric vision is going to be a major driver of change in the coming years.
It really is.
And it's up to us to shape that change in a positive direction.
It is. It's in our hands.
Any final thoughts for our listeners as we kind of wrap up this deep dive?
I would just say that geometric vision is this incredibly powerful and rapidly evolving field with a potential to revolutionize, countless aspects of our lives.
It really does.
It's important to stay informed about the latest developments.
Yeah.
Engage in these thoughtful discussions
Absolutely.
about the ethical and societal implications.
Yeah.
And work together to ensure that these technologies are used responsibly for the benefit of humanity.
Well said. It's been an amazing journey exploring the world of geometric vision.
It has.
We've covered a lot of ground here, from like the fundamental principles
Right.
to the mind-blowing applications.
Yeah,
And it's clear that this technology is going to play a huge role in shaping our future.
it will.
So, thanks for joining us on this deep dive, and keep exploring. The world of geometric vision awaits.